So in this video, we're going to be talking about what is function notation and how do I use it to evaluate functions. So in the last class, we learned about what a function was. So what's very special about a function is the fact that every single x value only goes to exactly one y value. So that is really nice. Because of that, we use function notation whenever I'm talking about this y. So this y is kind of, I like to think of it, it's a possession of the x. So f of x, that's what we kind of say. It's f of x. So like if I'm talking about f of 1 or f of 2 or f of 3, well, there's only one y value for this. And so we give it that, like, it's kind of like a name that we give for it. So it's the value of y for a specific x value. And so just knowing how to read this, and so if I have f of 1 equals 5, knowing how to read this is really important. Well, I know that I have the point where the x value is 1, the y value is 5. Now, if I have f of 0 equals 7, well, when the x value is 0, the y value is 7. And because it's a function, I know that there's exactly only one y value for this. So there's not going to be another f of 0. F of 0 is just going to be 7. Okay, so now let's use this function notation to go ahead and create a multiple forms of representation for this function. Okay, so right now we have a rule for this function. So it's a rule that's going to get us all of our y values. It's saying that f of x is equal to 5x. So this is basically saying that in order to get my y, I have to multiply x by 5. And every single time you multiply a different number 5 by 5, we're obviously going to get a different number. So this is going to be a nice function. All right, so it's saying that our x's need to be all the integers from -2 to 2. So let's go ahead and list out our x's. We have -2, -1, 0, 1, and 2. In order to get my y's, the rule says that I need to multiply x by 5. So I'm going to do 5 times -2, which is -10. 5 times -1, which is -5. 5 times 0, which is 0. 5 times 1, which is 5. And 5 times 2, which is 10. Okay, now what I want to do is just talk about how we would write this in terms of function notation. We have a set of 5 points here. Well, we have -2 and we have f of -2. We have -1 f of -1. And some of you guys are like, but shouldn't we write 5 here? Yes, f of -1 is -5, but I just want you guys to see this really quickly. So 0 and f of 0. And we have 1 and f of 1. And we have 2 and f of 2. So these are the coordinates we have. 2 f of 2, 1 f of 1, 0 f of 0, -1 f of -1, and -2 f of -2. So now we're going to write these just as regular points because we know the value of this. We just went ahead and computed f of -2, f of -1, f of 0, f of 1. All right, so let's go ahead. So here we have -2 and f. Let's write this in just a different color. That way y'all can see the difference between this. So we know that the x is -2. And our f of -2 is -10. And we have -1, and our f of -1 is -5. And 0, and f of 0 is also 0. 1, and f of 1 is 5. And 2, and f of 2 is 10. Okay, so this is the way we could write that in function notation. And this is the way we can write it because we know what the value is. Now let's go ahead and graph this. So our points are -2, -10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And our next point is -1, -5, 1, 2, 3, 4, 5, and then we have 0, 0, and then we have 1, 5, 1, 2, 3, 4, 5, and then our last point is 2, 10. So 6, 7, 8, 9, 10. And of course, this is looking like a line. We could have done, obviously, decimals, but it told us only in this case to do integers, and integers are not decimals, they're whole numbers. So we will not make a line through this because these are all the integers from -2 to 2. So now let's go ahead and do a map. So our map is going to have my x values here and my y values here. And so my x values are -2, -1, 0, 1, and 2. And my y values are -10, -5. Let's make that just a little bit more legible. -5, 0, 5, and 10. And this one is nice and boring. So -2 goes to -10, -1 goes to -5, 0 goes to 0, 1 goes to 5, and 2 goes to 10. Great. So this obviously again is a function, right? Because none of the x's repeat here, and every x goes exactly to 1y. My domain are my set of x's. It's -2, -1, 0, 1, and 2. My range is -10, -5, 0, 5, and 10. And now this is the key point where we want to get to. Point A is defined by f of -2 equals p. What's the value of p? So we need to find out what -2 is. F of -2 is. Basically we're trying to figure out the y value when we plug in a -2 for x. Okay, well, there are multiple ways that I can see this. I can see this on the graph. I can see this on a table. I can see this as a set of points. I can see this as a map. Let's look at the table. Well, when I plug in a -2, I get out a -10. So my value of p is -10. Okay, now here is a little bit different. It's saying that f of m equals 5. So I plugged in a number to my function. I plugged in an x, and I got out a 5 for y. Okay, so looking on this table, when did I get out a +5? Well, right here, what x value did you plug in? You plugged in 1. So a quick way that I like to look at function notation is that f of x is equal to y. My output is my y. The input here is my x. And so let's go ahead and apply this here. H of x is a function defined by this graph right here. If point D is defined by f of 1/2 equals t, then what is t? So my input here is 1/2. So that's your x. You're trying to find your output, which is t. You're trying to find your y value. So let's look at here at 1/2. Positive 1/2 is right here for your x's. And this is the only point that I have with a 1/2. And so my y value for this point is positive 2.5 or 2.5. What are we finding in words? Well, we're finding the value of y when x is 1/2. So this is really just sort of a reading exercise. So now let's try it again with the table. Okay, f of x is a function defined by this table. If the point h is defined by f of m equals 2, then m equals what? As a point right here, we have the m is my x value, my input, and the y here is 2. So what this question is asking us, it's basically asking us the value of x. We're finding the value of x when y is 2. Well, let's look at this table. When does that happen? When is y 2? It's 2 right here. What did I plug in? I plugged in the number 1. Now let's try it again. For the function p of 3 equals 5, and p of 5 equals 3. If y equals p of x, what is the value of y when x equals 3? Okay, so when I plugged in an x, right, I'm plugging in an x of 5. I'm trying to figure out what's the value of y. So let's look at our points. Well, this point right here is really the point 3, 5. This point right here is really the point 5, 3. So the value, which point is going to help me out? Well, not 3, 5, because this one doesn't have the value that I'm looking for the x. This one's going to help me out here. So what is the value of y when I plug in a 5 for x? 3. And what was I looking for? I was looking for the value of y when x equals 5. Alright, so that is the end of this video, and I hope that you found this useful for how to read function notation and understand it.